Guys, so Friday we began looking a little bit more in depth at each of the laws that Newton came up with. And so what we're going to do this week is we're going to work and look at examples of really the first and the third law. And then we're going to look really, really in depth and at a lot of data for Newton's second law, because that's where you get that relationship between force equals mass times acceleration. So this one says an experiment was set up, as seen in the illustration below, to explore Newton's second law of motion. A hanging mass, which is right here, was connected to a cart to provide a constant force. So this is the key thing. The force is constant, okay, causing it to accelerate. Mass was added incrementally to the cart, and resulting acceleration was measured. The data from this experiment can be seen in the table below. What I want you to do is I want you to analyze the data and write an explanation of the relationship between force, mass, and motion, citing evidence from the experiment. And so this one is one that if you're sitting in class, then I would take some time and let y'all do it. So what I want you to do now is I want you to pause the video. I want you to go to your worksheet, and I want you to type in what you think is happening. That way you can see if you're right or wrong. Okay, so at this point in time, pause the video, and we'll come back and we'll talk about it. All right, so now everybody should have taken a second to fill out all of the information. So what are some things we noticed from this worksheet? Well, first of all, we noticed that the force is held constant. So this is constant. And constant means that it is not changing. So every single experiment or trial that they do, this is important, the force is constant. And so what are they changing? Well, it looks to me like they're changing incrementally. So notice it's going up by 0.05 kilograms each time. They're changing the mass. So the mass is changing, and then what happens because the mass changes? It looks like the acceleration changes. Well, it does. Okay, so if I'm going from 0.25 down to 0.60, what am I doing to my mass as I move down? You are increasing the mass. So as the mass increases, what happened to the acceleration? So low mass, I had a high acceleration. As I move down, I have a high mass, I have a low acceleration. So my acceleration, as I increase my mass, my acceleration actually decreases. Okay? And so when you explain the relationship between force, mass, and acceleration, and I'm going to write this on mine, but you're going to have a little bit more examples with this. You would want to say, if force is constant, there is an, do you see how these arrows are going in opposite directions? That means there is an indirect relationship. So an indirect / inverse relationship between mass and acceleration. So what that means is as my mass increases, the acceleration decreases. What if my mass were to decrease? So it goes up, the acceleration would increase, okay? So as my mass decreases, my acceleration actually increases. So they have the opposite effect on one another. If they were directly related, so I'm going to write this over here, a direct relationship, they would either both go up, see my arrows, it's my shorthand, or they would both go down. So the next question, and on this one, when you turn this in, I want you to, because it says write an explanation citing evidence from the experiment. So on this spot, I need you to add evidence. And what is your evidence going to be? It's going to come from up here where you actually have data in the experiment. Okay. The next part says consider another approach to this experiment. If the mass of the cart were kept constant and the hanging mass increased incrementally, how would this affect the acceleration? So now it says, if the mass of the car were kept constant and the hanging mass, which would be my force, is changed, increasing or decreasing, well, it's increasing, okay, how would this affect the acceleration of the car? All right, so this is constant. How is increasing this number going to affect your acceleration? That's what the question is asking. So what I want you to do now is I want you to pause the video and I want you to type in your answer. And actually, you don't have to pause the video. I just want to see what your answer is. And remember, F equals M times A. And I want you to tell me why you think that they're either directly related or they're inversely related. Give me an example. It doesn't have to be data because you obviously have no data for this one. And so that's what you're doing with this worksheet. Okay, so you're going to type in this one, you're going to turn it in. And the other thing you're going to be doing is you are actually going to be working on Newton's second law and looking at diagrams. So it's going to be a sheet that looks like this. Okay, and I want you to show me your work as you're doing this. So you can either type in this or you can handwrite and make sure that it gets turned in. Okay, make sure that you include the correct units. If you have any questions about today's assignment, please message me and let me know. And then I will catch up with you soon.